Hi, everyone. So today is Wednesday, November 2nd. We are one letter behind. That's okay. So tonight at 8 p.m., we're going to have review sessions in TED Live, right? So please go to TED Live. You know how to go to TED Live? So here, Blackboard, TED Live Collaborate. And just click this one and then join the virtual classroom. Okay? All right. So tonight, please try your best to finish your practice exams before tonight, because tonight then you can ask me questions and then we can go over the practice exam. Okay, everybody? So for those of you who cannot attend tonight, I will make recordings. So after we finish, you can click the recordings and then you can see the recordings. Right, everybody? So when is our exam? Friday. Yes, Friday. From 12:20 to 1:50. So if you have a class before us, and at 12:50 and you still want to have the 1.5-hour opportunity, please email me as soon as possible so to schedule to take a makeup exam on Thursday afternoon. Okay, so I don't want you to leave your previous class early. That's not respectful to your instructor. Okay, so yeah, if you have conflicts, please let me know as soon as possible, then we can make arrangements. Okay, so any questions? So even though it's past the homework due date, but you can still submit your homework. Okay, so for all the previous homework, you can still submit that. The absolute deadline for your homework is the last Friday of class, which is December 9th. That is the last day I accept homework, all the late work. Okay, everybody? Because over the weekend, I will calculate your grade, and then our final exam is on the Monday, right? And then after I finish calculating your final exam, I will post your grades very quickly. Okay, so let's try our best. So do your practice exams. Make sure you understand every problem. If you don't, ask me tonight. And make sure you can remember all the steps. Okay. Let's continue. All right. So last time we talked about the 6 trig functions. Okay, let's review that. Sine is opposite over hypotenuse, right? So read with me. Sine theta is opposite over hypotenuse. Cosine theta, read with me. Cosine theta adjacent over hypotenuse. Tangent theta is opposite over adjacent. Cotangent theta is adjacent over opposite. Secant theta is hypotenuse over adjacent. Cosecant theta is hypotenuse over opposite. Very good. And then remember that hexagon help us to memorize the trig identities, right? The way how we write it is the natural order we read those 6 trig functions: sine, cosine, tangent, cotangent, secant, cosecant, and the one is in the middle. There are 3 diagonals. The product of the 2 ends equals the middle one, right, everybody? So that's why cotangent equals 1 over tangent, right? And secant is 1 over cosine. Okay, read it, say it loud. Cosecant is 1 over cosecant is 1 over sine, right? So tangent and cotangent, they're reciprocal. Sine and cosecant, they're reciprocal. Cosine and secant, they're reciprocal. Okay? What's tangent? Sine over cosine. Cotangent. Cosine over sine. And also there are three, I call them upside down triangles. You remember? The sum of the upper two vertex square is the bottom vertex square. So that's why the first triangle, we get sine square plus cosine square equals 1. Second triangle, tangent square plus 1 is secant square. The last triangle, 1 plus cotangent square equals cosecant square. Alright, everybody? So remember those trig identities like your name. So if I call you at midnight, hey, wake up, what's the trig identities? And then you can tell me. Yeah. If you want me to help you memorize it, give me your phone number. I'm gonna call you at midnight. Okay. Yeah. So last time we did 2 methods, right, to solve it. One method is use the trig identities, right? But usually when you take square roots of a square, you get plus or minus. And so that's why it depends on the angle. We have 4 quadrants, right? And it depends on the y is positive or x is positive or negative. You determine which quadrant. And then you can tell whether the trig function is positive or negative. So you can pick the solution. Okay, which solution is the positive root or the negative root? And then you can find the other trig functions. The second way is, okay, you use x, y, and r, and then you can let the x be that number 12, let the r be that number 13, and then based on which quadrants we're located, we can figure out the y. And then all your 6 trig functions, you can use those relation of x, y, and r to figure that out. Do you remember those 2 methods from last time? Yes. Very good. And also, this picture is very important. It tells us each quadrant how those trig functions, like the positive or negative. All right. So keep going. The unit circle. The unit circle is when the radius r equals to 1. All right. So we draw the x-axis and so, we have some handouts 5.2 to 5.3. If you need a copy, feel free and come and get it. Yeah. Okay. So we have the x-axis and the y-axis, right? Unit circle. Unit circle radius is 1. Okay? So unit circle radius is 1. Okay, so now we have okay. Yeah. So right here. Okay, so we draw this is theta. And then now you can see this is the x and that is the y. X is the horizontal distance, right? The distance from the point to the y-axis. And the y is the vertical distance, right? The distance from the point to the x-axis. And now you see r, the radius, okay? The distance from the point to the origin equals to 1. So therefore, sine theta is y over r, right? Opposite over hypotenuse. But because our hypotenuse is 1, so we get sine theta equals to y. I don't know why this changed to x. So it should be all theta. Okay, so change all as to theta. Okay, this should be theta, right? Okay, and cosine. Cosine is adjacent. Adjacent is x over r. But now you see r is 1. Therefore, cosine theta is x. And then tangent is still opposite over adjacent. Y over x. Cotangent, adjacent over opposite. So x over y. And secant theta, hypotenuse over adjacent, so 1 over x. And cosecant theta, hypotenuse over opposite, so 1 over y. So it's like the same formula, but we replace r by 1. Is that okay, everybody? Mm-hmm. That's the unit circle. Okay? All right, let's continue. So now we have this picture. Okay. So last time we figured out the points, the angles in degrees, and the radius, right? So these we have multiple of 30 degree and multiple of 45 degree. Right, everybody? Okay. And now this is a unit circle. So unit circle, the radius is 1. Okay, the radius is 1. Therefore, all these points, you can figure out the coordinates. Okay, so for example, look at this point. This point, what's the coordinate? Okay, so you have here, let's focus on this point. Okay, so this point, we have the x. Okay, this is the x, and this is the y. And because our radius is 1, so x equals cosine theta. Okay. So cosine theta, and you can see theta 30 degree. So therefore, the x value is cosine 30 degree, and cosine 30 degree is root 3 over 2. Okay, and y equals sine 30 degree, and sine 30 degree is 1 over 2. Okay, so we will talk about the special angle later. Okay, so there is a way to memorize the special angles 0, 30 degree, 45 degree, and 60 degrees. So we have later on we'll talk about a table. We can talk about the special angles and all the 6 trig functions values. So we will talk about that later. Okay, but this picture shows you that all the points on the unit circle, we can find the angle in degree mode and the radian mode, and we can also find the coordinates of the points. Okay, everybody, the coordinates, it has the property that x is the cosine of that angle, y is the sine of that angle. Okay, everybody? Yes. All right, sine and range of the trig functions. So combining the sine of x and y in the 4 quadrants with the definitions of the trig functions allow us to say the sine of the trig functions for any angle in a given quadrant. So I think we already did that before. Do you remember this picture? Yeah, do you remember this picture? Let me copy this picture and paste there. Okay, so let me copy this picture. So copy it and paste here. Okay, let me paste here. Let me put it here. Okay. All right, that's good. Okay, so now let's look at the picture. theta in the first quadrant is what? Positive. Second quadrant, positive. And because sine is y over r is always positive. And you see, on the top two quadrants, the y is positive. So sine theta is positive. So sine theta, positive. Okay, so positive, positive. But in the third and fourth quadrant, the sign is negative. Yay, so negative, negative. So that's sine. Okay, sine, positive, positive, negative, negative. Okay, how about cosine? Cosine is the x over r. So here, do you see on the right hand side, x is positive? In the first and the fourth quadrants is positive. And then in the second and the third quadrants, negative. So the first and the fourth one is positive. The second and the third one is negative. Tangent. Tangent is sine over cosine. Positive over positive is positive. And then positive over negative is negative. Negative over negative, positive. Negative over positive, negative. Yes, everybody? So actually, after we know sine and cosine, you can deduce the rest. Because tangent is sine over cosine, right? So after we know sine and cosine, we can deduce the rest. Cotangent is 1 over tangent. That means they have the same signs. Yeah, everybody? So positive, negative, positive, negative. Secant is 1 over cosine, right? Yeah? And so this sign should be the same as cosine, right? So plus, minus, minus, plus. So far, if you come in late, don't forget to check out the recordings and make sure you don't miss, those things. And tonight, we have review session at what? 8 p.m. You go to TED Live. Okay, don't go to the classroom. Nobody is here. So TED Live, right? Okay, cosecant. Cosecant is 1 over sine. So the sine should be the same as the sine theta. So plus, minus, minus. Okay. Now, number 8. State the sign of the 6 strict functions. Again, first quadrant, our angle goes from 0 to 90 degrees, right? Second quadrant from 90 degree to 180. Third quadrant, 180 to 270. And the fourth quadrant, 270 to 360. Yes, very good. 97, which quadrant? Second, right? So quadrant 2, right? And then you get, so wait, it just calm me down, see? Sine is positive, cosine negative, tangent negative, cotangent negative. Secant is what? Negative, and cosecant is positive. Is that okay, everybody? Yeah, if you want to draw the picture, 97 degree is kind of right here. See, this is 97 degree. So the right angle is 90 degree, 97 degree is a little bit bigger than 90 degree. And then we know, quadrant 2, here. So then you can write it down. So far, so good, everybody? Yes, awesome. Okay, 260 degree. Which quadrant? The third one, right? The third one. Oh, see? The third one. So this is 260 degree, the third one. And now you can write down the sign, see? You know the sign is negative, cosine, negative, tangent, positive, cotangent, positive, secant, negative, cosecant, negative. Is that okay, everybody? Mm-hmm. All right. Yeah, so in the exam, it's good to figure out this. And then it depends on the angle in which quadrant, then you just look at this picture and figure out. All right. How about theta is minus 80 degrees? Quadrant 4. Very good. So remember, we can add a multiple of 2 pi, which is 360 degrees, or we can subtract multiple of 360 degrees, right? So that's why the four quadrants, you can think of this as minus 90 degrees to 0. Yeah, you can think it this way. So minus 80 degrees is in quadrant 4. And remember, if the angle is positive, that means we go counterclockwise. If the angle is negative, it means we go clockwise. Yes, everybody? Mm-hmm. So this is quadrant 4. Therefore, quadrant 4, we're here. So copy down. Sine is negative. Cosine positive. Tangent negative. Cotangent negative. Secant positive. Cosecant negative. Yes, very good. Bless you. Okay. Now, which quadrant is the sine is negative, but the cosine is positive? Quadrant 4. Sine is negative. Remember the sign? The top 2 is positive, the bottom 2 are negative. So the bottom 2 quadrants. But cosine is positive. Cosine is positive for the first and the fourth quadrants. That's why this must be in quadrant 4. Is that okay, everybody? Yeah, so sine is negative. Well, that's quadrant 3 or 4. Cosine is positive. That's quadrant 1 or quadrant 4. And then that's why it must be quadrant 4. So this is how we think. Is that okay, everybody? Okay. Which quadrant is the cotangent negative and cosine negative? So which quadrant the cotangent is negative? Quadrant 2 and 4. Right. So quadrant 2 and 4. And which quadrant the cosine is negative? Quadrant 2 and quadrant 3. And then the common one is quadrant 2. Right, everybody? Yes. Okay. So this is how we can figure out the sign of the 6 trig functions. Right. Keep that picture in mind. Okay, range of the 6 trig functions. Okay, so we call that, let me put this as 1, okay? Because I don't want to draw a very tiny circle. Let's make this be 1 and draw a bigger circle, then we can see it. So then this is 1. We draw the circle. Okay, this is a circle, right? And this is the x, and that's the y. This is the theta. And we know x over 1 is adjacent over hypotenuse is cosine theta. Y over 1 is sine theta. Yes, everybody? Now, let's look at the range of it. Okay. Now, can you see when the points go around the circle? Look at your x. What's your x value? Well, if the point is right here, my x is 1, right? If the point go here, my x is decreasing. And at this point, my x is 0. And then here, my x is -1, right, everybody? And then the point go, continue, right? How about here? The x is 0, right? And then we go here. The x is 1. Do you see the x is bounded between -1 and 1 when we go around the circle? So we know x is between -1 and 1. Therefore, the cosine theta, yeah, cosine theta is x when we go around this unit circle. So cosine theta is bounded between -1 and 1. Okay, so therefore cosine theta, interval notation, -1 and 1. And you want to use set builder notation, you can say, oh, that's the number a such that a is bounded between -1 and 1. Yeah, you can use any letter. You can use X or T or W or A, right? Any letter. That's the set builder notation. And this is the interval notation. Okay, so X is the cosine theta. Y is the sine theta. Let's look at this point. What's the Y value? 0, right? And then we go, how about here? What's the Y value? 1. And then we go, how about the Y value here? 0. And we go, how about the Y value? -1. And then we go back here, 0. Do you see our Y is bounded between -1 and 1? That's the range, right? Okay. So y is bounded between -1 and 1. Y is sine theta. Therefore, our sine theta is bounded between 1 and -1. So interval notation, -1 to 1. And then the set builder notation, you can use the same A, right? It doesn't matter what letter you use. And it's bounded between -1 and 1. So far, so good, everybody? Okay, now let's increase difficulty. Tangent theta. So tangent theta is y over x. Yes, so keep in mind, do you remember 1 over 0? We say that's undefined. 1 over 0 plus is infinity, yeah? 1 over 0 minus is negative infinity. Yes, everybody? Okay. Y over x. Let's look at this point. This point, the x is 1. The y is 0. Do you agree at this point is 1 comma 0? So the x is 1, the y is 0. So if we use y over x, 0 over 1 is 0. So at this point, the tangent theta is 0. Right, everybody? Okay, now we keep going. How about this point? This point is at 0, 1. Oh, do you see y over x? when you are going to, are you able to see my blue arrow? We're approaching to this point. We're not equal to this point. So when we approach this point, my x is going to 0 from the right. Do you see, everybody? So my x is going to 0 from the right. From the right because it's positive. Yeah. And then do you see the y? The y is going to 1. Therefore, y over x, it goes to 1 over 0 plus. That is infinity. So when we approach this point from the right, my tangent goes to infinity. Yes, everybody? Mm-hmm. On the other side, okay, on the other side, if we approach this point from the left, do you see we get 1 over 0 minus? That's minus infinity? Yes? Everybody? So, therefore, my tangent values goes from minus infinity to positive infinity when you go around the circle. Okay, so if you are here, that is what? 0. This is 0. Let me get that right color. Just minus 1, 0. So 0 over minus 1 is 0, right? And then here, see, you're going to this point is 0 comma minus 1. Minus 1 over 0 is undefined. But if you're going from this side, you have what? Minus 1 over 0 minus. That's positive infinity. And then here, you get what? If you do this direction, you get minus 1 over 0 plus. That is minus infinity. Yes, everybody? So that's why we can see our tangent is from minus infinity to infinity. Is that okay, everybody? So how do we write that? We just say A. A is any real number. Or we just say it's a set of all real numbers. Okay. All right. Cotangent. Cotangent is 1 over tangent. Is that okay, everybody? So if our tangent can be from minus infinity to infinity, then our cotangent, same thing. Right? Or you can think of another cotangent. Look at this picture again. At this point, so cotangent x over y. Do you see 1 over 0 is undefined? Yes, everybody? But when we're approaching this point from the top, we get 1 over 0 plus. That's infinity. Yes, everybody? And if we approach from the bottom, we get 1 over 0 minus. That is negative infinity. Yes, everybody? So can you see the cotangent range is from minus infinity to infinity? Can you all see that? Yeah, so the set builder notation, we can just say R. Okay. What's cosecant? 1 over, bless you, 1 over cosine. Right, everybody? Okay. Now, let's see. Okay. We have, okay. So how do we figure out 1 over cosine? By the way, 1 over cosine, if we want to have the secant, 1 over 0 is not defined, right? And then so you have to split. If cosine is positive, what happens? If cosine is negative, what happens? Okay, so let's look at the cosine range. Cosine range is between 1 and minus 1. Okay, let's separate into two cases. Okay, So let's separate into two cases. Okay, so if two cases, if cosine is positive, okay, and then cosine is positive, so cosine is bounded between 1 and minus 1. Let's say it's positive, then we have 1 is square equal to cosine theta. Right, everybody? When you flip it, become 1 over cosine theta, and then the other side 1 over 1. Do you know that when you flip it in the denominator, your inequality sign will flip? Think about it. 2 is less than 3, right? If you flip it downstairs, what happens? 1/2 is bigger than 1/3. Yeah? So, oh, that's why 1 over cosine, bigger than or smaller than? Bigger than or equal to 1. Oh, see, we get secant is bigger or equal to 1. That's the first case. Second case, if cosine theta is negative, well, then we know it's bounded between -1 and 1 is negative. So cosine theta is greater or equal to -1. Yes, everybody? Flip it. 1 over cosine theta is then what? 1 over -1 is -1, but what happened with the inequality sign? It flipped, right, everybody? So we get less than or equal to. So we get secant theta is less than or equal to -1. So our secant theta value is less than -1 or greater or equal to 1. Okay. All right. So minus infinity to -1, union 1 to infinity. For those of you who are looking at my notes online, you see I have a mistake there. Okay, so in the class notes online, I forget about this piece. It should be 2 intervals, union them. So then secular notation. A is less than or equal to -1, or A is greater or equal to 1. Is that okay, everybody? Yes. Okay, cosecant. Cosecant is 1 over what? 1 over sine. Okay. Do you see sine and cosine are so similar? Sine is bounded between -1 and 1, and cosecant is 1 over sine. So you can use the same proof. You get cosecant is the same interval as the secant. Right, everybody? Yeah. Yes. Okay. All right, so we have minus infinity to -1, union 1 to infinity. And A is less than or equal to -1, or A is greater or equal to 1. Okay. Yes. I know this phase might be new to you, so it looks like a lot of things. Later, we will talk about the graph of the 6 track functions. It's easier to view all these on the graph. Okay, so if you cannot quite remember right now, it's okay. Later on, when we learn the graph, it's very easy to look at the graph and figure out the range and domain. Okay. All right. Now, state whether it is possible for cosine theta is -28. Is it possible? No. Cosine theta should be bounded between -1 and 1. -28. No way. Is that okay, everybody? Is it possible when the cotangent theta is -129? Yes. right? Because cotangent theta minus infinity to infinity. So any number is possible. Is it possible for the cosecant theta is 0.5? No, right? It should be either less than or equal to minus 1 or greater or equal to 1. It cannot be 0.5. So, no. So far, so good, everybody? Awesome. Okay, let's see. Suppose theta is in quadrant 3 and tangent theta equals 5 and over 9. Find the values of the remaining 5 trig functions. So two methods. One method is use the trig identities. Which trig identities involve tangent theta? What? Sine over cosine. That's one way. Okay. But there's another trick identity involved tangent. Yeah, exactly. So that formula, tangent squared plus 1 equals secant squared, we can use that trick identity to help us to figure out secant. Okay? Once you figure out secant, then you can find the remaining 6 trig functions. So that's method 1. Okay, everybody? Method 2. You remember tangent is what? Opposite over adjacent. So y over x. Yeah, everybody? So we can then let the y be that number, let the x be that number. So I'm gonna use that method, okay? So I will use method 2, but you can also use method 1 to solve. So I use method 2. Tangent theta is y over x. That's 5 over 9. But what happens? That angle theta is in the third quadrant. Third quadrant. So that means our x is negative, our y is negative. Do you agree? Yes, everybody? So you cannot let y be 5, x be 9. They should be both negative. So what do you let x to be? Let x be negative 9. And let y be negative 5. Right, everybody? So awesome. We let the x and y and the r by the Pythagorean theorem. Yeah? R is square root of x squared plus y squared. Are you okay with that? Yes. Okay. So therefore, square root of negative 9 squared plus negative 5 squared. What's negative 9 squared? 81. What's negative 5 squared? 25. Oh, what's that? 106. Right? Everybody? Yeah? Okay. Now, bless you. We're ready. Because now sine theta is what? Opposite over hypotenuse. Your opposite is x or y. Y. So y over r. Y is negative 5. R is square root of 106. Yeah? What's cosine? What's cosine? X over r. What's your x? Negative 9 over, the square root of 106. Yes, everybody? Okay, what's cotangent? Cotangent is 1 over tangent. Oh, 1 over tangent. What's the reciprocal of our tangent? 9 over 5. Yes, everybody? So I hope you can be familiar with all the trig identities. That's very, very important. Okay, so every day we learn something new. So please remember those formulas, review your notes. Okay, how about secant theta? 1 over, what's secant? 1 over cosine. What's the reciprocal of cosine? See? Flip it. We get root of 106 over 9. Yeah? How about cosecant? That's 1 over what? 1 over sine. The reciprocal of sine is square root of 106 over 5. Is that okay, everybody? Yes. So I would suggest use method 2. I think, yeah, because you can let the x, let the y, and then you can figure out the r, and then you can find all the trig functions. Right, everybody? Okay. All right, keep going. So, quadrant 4. What's cosecant? R over y. Right? Quadrant 4. Quadrant 4, your x is positive or negative? Positive. Your y is negative. Yes, everybody? So, what do you set your r to be? Bless you. R is compare. Compare. Two questions. Can your R be negative? No, R is always positive. So you let R to be 2. And then you let the Y is negative square root of 3. And let's check. See, quadrant 4, our Y is negative. Okay, great. How do we find the X? See, R, and this is Y, this is X. By the Pythagorean theorem, you have what? X squared plus Y squared equals R squared. So what's X squared? R squared minus Y squared, yeah? So we get R squared is 4, right, everybody? What's Y squared? What's negative square root of 3 squared? Okay, here, gotta be careful. Negative 1 squared is plus 1, but we still have negative in front. So that's 3 negatives. That 3 negative gives us negative. Square root of 3 squared becomes 3. Is that okay, everybody? So 4 minus 3 is 1. So x should be plus or minus 1, but which number do we pick? Quadrant 4. Which number shall we pick? Positive. So pick x equals to 4. Because we are in, because we're in quadrant 4, x should be positive. Is that okay, everybody? Questions? So we let the r be that number, let the y be that number, and then hopefully we can get the other variable by Pythagorean theorem. So when you take square roots, you get plus or minus. So it really depends on which quadrant that one is located. And then you can figure out whether the number should be positive or negative. Because it's in quadrant 4, the x should be positive. So it's the positive number. If I I tell you the point is in quadrant 2, then what happened? Your x should be negative. Okay, good. So after we figure out all the x, y, and r, we can write down all the 6 trig functions. What's sine theta? Y over r. Y is negative root 3 over r. R is 2. Right? By the way, you can move the negative on top, or you move the negative in front, or you move the negative in the denominator. They're all the same. But I usually like to move the negative outside of the fraction. Okay, but they're all the same. You can express it in any way you like. Okay, how about cosine theta? X over r. X is 1, r is 2. Yes. And how about tangent theta? Y over x. Y is negative root 3 over 1. Yeah? So just negative root 3. Everybody? What's cotangent theta? 1 over tangent. So you see, 1 over that is the 1 over that. Okay. So by the way, this answer is fine. You don't have to rationalize your answer. So you don't have to put root 3 over 3. Is that clear, everybody? I actually prefer this form. This is a simplified form. Okay. How about secant over cosine, right? That is 1 over cosine is 2. Maybe I should put this right here because it's after the cosine. And then the cosecant, we already get the cosecant. Yes, everybody? So we get all the 6 trig functions. Okay. Any questions about this problem? If you can understand, raise your hand. All understand? Raise your hand. Yeah? Okay. Okay. All right. Now, this is a table I'm referring to. Okay. So, the angle theta. The theta can be a special angle, okay? And remember the special angle. So this is 0, this is 90 degree. And then if you put it like 3 pieces, then this is 30 degree and this is 60 degree. And you put it into 2 pieces, then this is 45 degree. Okay, the special angles, they are 0, 30 degree or pi over 6, 45 degree or say pi over 4, 60 degrees or we say pi over 3, and 90 degree, which is pi over 2. Okay. And then usually we look at the sine first. Okay. I don't know why the cosine and sine switch. I just print screen the picture from some textbook. Okay. So you look at the sine. Sine of 0 is 0. Okay. Sine of is 0. And then because why is that? Sine is like the opposites over hypotenuse. So y over 1. Okay? Do you see at this point the y value equals to 0? So that's why this is 0. And the rule is square root. You can think of the rule is square root of n over 2. And you let the n goes from 0, 1, 2, 3, 4. So this is the rule, how to help you memorize this. Think about it. See, when you plug in n is 0. 0 over 2 is 0. When you plug in n is 1, you get 1 over 2, which is this number. When you plug in n is 2, root 2 over 2 is right here. When you plug in n is 3, root 3 over 2, right here. And you plug in n is 4. Do you see square root of 4 is 2? 2 over 2 is 1. So you use this formula. It helps you to remember these 5 numbers. Is that okay, everybody? So this is just a rule to help us memorize. Okay. So square root of n over 2, and you let n goes from 0 to 2. Okay? And then, after you memorize the sine values, the cosine value, same number, but reverse order. That's why 1 here, put the 1 here. Root 3 over 2, put the root 3 over 2. Root 2 over 2, here. 1/2 here. 0 here. It's the same number, but reverse order. Is that okay, everybody? Yes? So you figure out the sine using this rule, and the cosine. Same number, okay, same number, but reverse the order. So this is how we can remember the cosine numbers. Next, tangent. How do we remember tangent? Well, tangent, you use sine over cosine. So after you figure out the sine and cosine value, you can deduce the rest. Look at this, sine over cosine. Look at this, 0 over 1 is 0. Yes, everybody? 0 over 1 is 0. And then here, 1/2 over root 3 over 2. So 1/2 over root 3 over 2. Do you see the 2 cancel? You get 1 over root 3. 1 over root 3 is the same as root 3 over 3. Okay, everybody? And then here, oh, do you see this guy over this guy? Because they're the same. So we cancel them, we just get 1. Yeah? And then here, this guy over this guy. So root 3 over 2 over 1/2. Do you see 1/2 cancel? You just get root 3. Yes? And then here, do you see 1 over 0 is undefined? Yeah, 1 over 0 is undefined. So you figure out the sine values, the cosine values. Tangent is sine over cosine. Cotangent, and then you look at cotangent. Cotangent, same values as tangent, but reverse order. Okay? So cotangent, same values as tangent, but reverse order. That's why undefined. Root 3, 1, root 3 over 3, 0. Is that okay, everybody? Cotangent values, same values as tangent, but reverse order. Now, secant. What's secant? 1 over cosine. See? Look at my cosine. 1 over 1 is 1. 1 over that, the reciprocal of that is 2 over root 3. But 2 over root 3 is the same as 2 times root 3 over 3. And then 2 over, do you know 1 over root 2 over 2 is 2 over root 2 and root 2. And the reciprocal of 1/2, see, is 2. And then, what happened? Okay, and then here, 1 over 0, see? Reciprocal of 0 is undefined. So we look at the cosine values, we can figure out the secant values. Cosecant values, what? Same number as the secant, but reverse order. So therefore, this is secant. Reverse order. Undefined 2, root 2, 2 root 3 over 3, 1. So this is how to get all the 6 trig functions with those common angles. And when you do your homework, try for the special angle. Try not to use your calculator because you are supposed to memorize this. If you use your calculator, it only gives you decimals. we want exact numbers. Okay, we want root 3 over 2. We don't want to do that. Okay. Any questions about this table? No? Okay, so we know the rules. So how do we get those numbers? Okay, so let's keep going. Okay, reference angles. So an angle's reference angle is the acute angle T prime formed by the terminal side of the angle and the horizontal axis. So the horizontal axis is the x-axis. Okay, so the angle between the terminal side and the horizontal axis. So that's why you have this picture. If our angle T, so T is the actual angle T is in the first quadrant, then our reference angle, okay, the angle made with the x-axis is also T. So T prime equals T in this case. But if our angle T is in the second quadrant, now do you see my T prime? The T prime is the angle made with the terminal side and the x-axis. Do you see this is the angle? And do you see this angle is pi minus t? Yeah, so t prime is pi minus t. And how about if the point is in the third quadrant? Okay, so in the third quadrant. Now, do you see this angle? The t prime is the t subtract the pi. Right, everybody? So the t prime, the reference angle, is t subtract the pi. So t minus 180 degrees. And if the angle is in the fourth quadrant, then this angle will be 2 pi minus t. Okay, so you can imagine this is like the negative t, but you add 360 degrees to it. So this is what you get. Okay, so T prime, the reference angle, is always the angle between the terminal side and the horizontal axis, which is the x-axis. So therefore, how do we figure out this? First of all, you want to know which quadrants the angle lies in. So 225 degrees is in which quadrant? The third one, right? The third one is between 180 to 270. So 225, like here. Okay, so how do we get this reference angle? See? 225. We want to subtract 180. So 225 subtract 180, and that is 45 degrees. Okay, the reference angle is always between 0 and 90 degrees. Good. Okay, how about 7 pi over 6? Which quadrant? The third one, yes, because this is pi. This is 3 pi over 2. So 7 pi over 6. What do we do? Subtract pi. We get pi over 6. Yes, everybody? Okay. Now, use reference angle. Find the exact value of cosine 150 degree and sine 150 degree. Where's 150 degree? Which quadrant? The 2. Okay, everybody? The 2. So, 150 degree is right here. What's this guy? The reference angle is what? 180 minus 150, which is 30 degrees. Yes, everybody? Okay. So if the reference angle and the actual angle, they have the relations that the sine and cosine value are the same or off by a sign. Look at this angle. This angle, our sine is positive or negative? Okay. So sine is positive or negative? Positive. Cosine is negative. So therefore, cosine 150 degree equals negative of cosine 30 degree. Cosine 30 degree, if you can remember, look at this. Cosine 30 degree is root 3 over 2. Yes. So that's why we have negative root 3 over 2. And sine 150 degree. See? Second quadrant, sine is positive. So that equals to sine of 30 degree. And sine of 30 degree is what? 1/2. Good. So what happened? So that's 1/2. Okay. Yes. 1/2. Okay, so let's continue next class. We use the reference angle. The sine cosine is always the same value or the opposite sign.
What time is the technology?
Oh, it's the virtual classroom. So you go to the Blackboard.
I know where it's at. What time is it?
Oh, 8 p.m.
Okay.
Yes, 8 p.m. So see you tonight in the virtual classroom.